Hello, I am Edward Cacho, and today I am going to show you how to build real-time chat applications with the actor model. This is my LinkedIn if you want to talk with me. The agenda for today, and let's go with the chat demo. This is the real-time chat application, and the look and feel is like a terminal application. This app works like a Zoom or Google Meet. You can create rooms and invite to your friends. This is the home page. Just press enter to create a new room. So write your name and that's it. You can now chat with everybody that is in the room. You can share the link to your friends. We need to open this in a new window. And the new user is Steve. So the system says welcome Steve when everybody joins to the room. Steve says hello. If we go back to the first tab, we can see system says welcome Edward, system says welcome Steve, and Steve says hello. Now we can replay hello Steve. If we go back to the follow to the second tab, we can see the message from Edward. So how this works? Behind the scenes, we have actors. Uh, every user has an actor, and these actors are communicating between them to provide this feature. We can create many rooms. We can join as many people as we can. For example, here we are going to create a new user. No? Uh, the new user is beer. Hello, everybody. And here we have the message from everybody. We can replay hello beer. And we can see our message here. And beer can see the message from Steve. And Edward, we can see all the messages. And we can see the logs. What is going on with the running application? We can see actors are sending messages. The actors has socket to maintain the communication because uh, when a new user joins to the chat room, it creates a WebSocket. And in the backend, that WebSocket is tied to an actor. We will see the design later. So this is how it works. Before showing the code, a quick introduction to the actor model. This is a concurrent computing model that is very powerful to build high concurrent applications. The main important thing with this model is the actor. The actor is the basic unit of computation. In the case of the real-time chat, we need to design the application thinking in actors. But first, what is an actor? Basically, an actor has three main characteristics. First one, processing. The actors can do something, can do computations. It can even create other actors. A state, it can have their own private state. Nobody can access to their state. This avoids that raise condition problems. And communication. It can send messages to other actors. When an actor receives a message, the actor can do something about the message and can reply with other messages to other actors. Now, let's talk about how to design the chat web using the actor model. The use cases are create room, join room, and send message. So the actor system is this. Every circle on this design is an actor. The room manager, this actor, is responsible to create chat rooms. As you know, using the actor model, everybody is an actor, so room manager actor, when it needs to create a chat room, it creates a room actor. The room actor is responsible to send messages to every user. The guest actor is responsible to send messages from the user's browser to the room actor in both directions. First use case, create room. We have basically three parts of the application. The client, the backend itself, written in Blade framework, and the actor model. The client uses their web browser to communicate to the web application. Basically, it goes to the controller using the HTTP protocol to the run create endpoint. The web application basically sent a message to the room manager saying the create message to the room manager, and the room manager responds with another message, the run created message. So the web application knows what is the room ID. So with this room ID, the web application redirect the user's browser. The room manager has their own state. The state is that list of rooms, and every room has their own unique ID. Second use case, join to the room. So the web browser, after the redirection in the previous step, the web browser goes to the web application, to the endpoint chat slash room ID slash WS. Basically, this creates a WebSocket connection. The backend with this request, it's communicate with the actor model using defined room message, and the room manager responds with the room address message, and then it creates a guest actor, and this guest actor is tied with the web connection. So the state of the guest actor is the web socket connection and the room address previously obtained by the room manager. After that, the guest actor sends a message to the room uh, to join. And the state of the room actor is the list of guests. And how to send a message. At this point, we have three actors, the room manager, the room, and the guest. So we only need to send messages from the guest to the room. So when the user writes something in the web browser to send a message, it goes through WebSocket. This message is obtained by the guest actor, and with this message, the guest actor send a broadcast message to the room actor, and this room actor has a list of guests, so basically send the same message to every guest on his state. And the guest actor, when receives the message from the room actor, basically communicates this message to the client through the web socket because the guest actor has the socket connection in his state. So this is the design. What is the stack? I use Vue.js for the frontend, Aka to design the actor model, Play framework to create a web application to expose web application using the HTTP protocol, and Scala. Now let's talk about the code, how to implement every use case with all this library I mentioned. Let's review the code for the first use case. Create a chat room. Here, this is the chat. When you press enter, automatically the browser makes a get request and goes to this controller, the room controller. The room controller inject the room manager and send a message to the room manager, create maps to room created. This is the response that is expected. And after that, just redirect the browser to chat and with the room ID. To be able to inject the room manager, first we need to create that object. We can do that with creating a module class. We can configure, we can bind actors here. So we can bind the room manager actor with the name room manager. After that, we can inject in the room controller the room manager. As the design describes, the web browser goes to the controller sends a create message to the room manager, the room manager responds room created, and we redirect the browser to the chat room. Basically, this is what it does this a few lines of code. We can go to the room manager actor to see what is going on here. This class, the actor, basically needs to define what are the messages that the actor can process. So we need the object room manager actor. Basically, those are the messages. The object, the create message, the guess by room message. But let's focus on the creation of the room. So this is the implementation. Room manager actor extends from actor class, and we can receive messages. And this is all the messages that we can receive and process. So what is the state of the actor? Basically, the state of the actor is a map of rooms. This is the room ID. This is the address of the actor. We need the address of the actor because we need to send messages to the room. So when we receive a create message, basically we create a new ID. We create a room actor with this ID. We watch this actor. When we watch the actor, we can know when the actor dies. Then we change the state. we have a new room in our state, and to the sender, we send a message, room created. So if we receive a create message, finally, we respond with room created message to the sender. And who is the sender? The sender is the room controller. So we expect room created message. This is the message. And here we redirect the user. This is how the room manager works. Really simple feature. Let's continue with the another use case. Join to the room use case. So what's happened? When the user goes to this page, chat and room ID, the backend needs to send the HTML content. So the backend needs to find what is the room ID, if exists or not. If exists, just render the page. This is the view code, but we are not covering this part. If not, if not exists, just go to the home page. So what happened with find room? Find room is really simple. The room manager needs to return what is the address of the room actor. So the room manager actor implements the find room message. If we go here, the find room message is really simple. It's just find the rooms in the map and reply to the sender room found with an option of an address. That's it. When this page is rendered, the browser creates a WebSocket connection. If we go here, here is the implementation. We can create socket connection with this, WebSocket exit or result. We need to create here, according to our design, a guest actor with this socket connection and the room address. So we need to find it by room ID. If we have the room address, now we can create the socket connection with an address of an actor, actor flow, actor ref. So out is an address of an actor. It's like an instruction of the WebSocket. So we need to create the guest actor with those two values because this is the state. So here's the implementation. When the guest room is created, automatically send a message to the room actor with add guest message. If we go to the implementation of this, it's really simple. It's just adding to the set of guests, and that's it. A really simple implementation. So if we come back, this is the implementation for join to the room feature. Really, really simple.
Now, the last part, use case send message. To make this chat works, every user needs to receive the messages from the other users. Let's go back to the design. If you notice, the room actor is responsible to send the message to every user, but first, this actor needs to receive a broadcast message. Let's review the implementation. Let's go to the guest room actor. So we have this. We receive basically two kind of message. This message is coming from the chat room. If we receive a message from the chat room, we basically just send the same message to the socket. This is the socket, the web browser. If we receive a message from the socket, we need to process that message. This is a simple implementation. If the user sets the username, we send a broadcast message, system welcome, like this. Enter, what is your name? Edward, enter. This is this part. We are sending the broadcast message, system welcome, Edward. If not, we send a broadcast message. So let's go to this implementation. This is a message from the room actor, and basically this is really simple because this broadcast message, when this actor receives the broadcast message, basically iterates the guests, all the guest actors, and send a message to every actor. Let's go to the web, share this, copy link, and here Steve is the name. Yeah, if we go back here, we can see welcome Steve, because this guest actor is sending a broadcast message, and we have one room actor. And when this happens, basically we are sending the same message to every user. So if we hello Steve, so we are sending a broadcast message and we receive the message. Yeah, that is how this works. Simple implementation if we design a chat application using actors. Basically every user is an actor, and those actor belongs to a room, and this room basically sends the message to every actor in this room. And yeah, it's a really cool technology, the actors. I hope you learned something new from this video. These are the links you could use to learn more about the actor model and ACA, and the link to the source code. Next video, it could be do the same chat application but using SEO, SEO HTTP, and SEO actors. Until next video,